We will first have some introductory remarks from both the Director of International Activities, Torben Brabo, and the Vice President of Corporate Strategy and Business Development in Gasunie, Hans Könen. Then I will be talking about the hydrogen supply potential in Denmark. Afterwards, Dr. Malte Grunwald will be talking about the hydrogen demand potential in Germany. And lastly, Tine Lindgren, who's the Chief Engineer at Energinet, will be going through the case study analysis that we made, touching upon some of the technical aspects of the study that we made. And as also mentioned before, there will be a Q&A session in the end. So we should be able to get through the session and finalize a 3:45 this afternoon. With those words, I would like to give the first words to the Director of International Activities, Torben Brabo. Torben, the floor is yours.
Thank you, Louise, for the introduction. Please say if you can't hear me. Welcome everyone attending this webinar. Energinet is very pleased to present a joint pre-feasibility study on hydrogen infrastructure made in collaboration with our good colleagues from Gasunie. This study is one of several hydrogen studies Energinet is involved in. It includes our national system perspective studies as well as our participation in the European hydrogen backbone studies. Such studies are very important to prepare to fill in the missing blocks of information and understanding we need to prepare the overall EU energy transition. With this new study, we try to dig deeper on a specific infrastructure pathway between Denmark and Germany, considering design aspects and indicative cost estimates. We as TSOs have deep technical competences and experience with molecule gas infrastructure development, something which should be exploited in the development of hydrogen infrastructure. Even if the main driver in the energy transition is electrification, we need molecules and liquids as either energy or feedstocks to be successful towards 2030 and 2050, in particular in those sectors that are technically difficult or very expensive to electrify. So while electrification and energy efficiency is critical for the decarbonization of the EU energy sector, system integration and system efficiency is equally important to ensure that we have a successful decarbonization of the hard-to-abate sectors. The political ambitions on offshore renewable energy as laid out in the EC's offshore renewable energy strategy require cost-effective integration of renewable energy sources. In the absence of market models and infrastructures for both electricity and gases, including hydrogen, we will not be able to exploit the full potential of renewable energy capacity. So it's not a coincidence that the Commission launched the strategy for both sector integration and on hydrogen on the exact same day last year. These strategies should be seen together. As the national TSO for both electricity and gas in Denmark, Energinet is committed to find ways to support the green transition of the energy sectors by developing new market models and incentives which ensure higher integration of renewables in the energy system, moving energy easily across sectors while keeping the overall costs of the systems down and maintaining a high security of supply. EU's industrial policy points as hydrogen as a key technology in realizing the EU Green Deal of carbon neutrality by 2050. With the launch of the European Clean Hydrogen Alliance and the IPCEIs on hydrogen, the EU policymakers have shown the critical importance of developing the hydrogen value chain to unlock the potential of an EU hydrogen economy. The industry has embraced the initiative and more than 1,000 companies, NGOs and ministries have joined the European Clean Hydrogen Alliance. We understand that up to 2,000 projects have been submitted to the Clean Hydrogen Alliance roundtables, including projects on repurposing and retrofitting of existing natural gas infrastructure. Alongside the producers of renewable energy technology providers, consumers, the energy infrastructure operators for storages and transmission are a key part of the puzzle of building the new hydrogen value chain. EU countries have widely different starting points for the EU energy transition. Thus, we need to find different ways to harvest the comparative advantages of the different EU countries. Both around the North Sea and in Southern Europe, we either have immense offshore wind resources or large solar PV potential and can become new production centers for renewable energy in the European Union, including hydrogen. And countries like Norway, with the abundance of natural resources, has the potential to produce significant amounts of low-carbon hydrogen. In Central and Eastern Europe, their focus are mainly on coal-to-gas conversion, and green gases come at a slower development pace. The potential for import of hydrogen from overseas is also important to realizing the EU 2030 goal of 40 gigawatt imports, and other countries have lower potential for renewable energy production, but they have a significant demand potential. So we are all different, but we can play important roles in the EU energy transition. Coming back to this study, it exemplifies that Denmark has an abundance of renewable energy sources, particularly offshore wind. Since the potential far outweighs the classical and even future energy demand in Denmark, a share of the renewable hydrogen produced in Denmark could be exported to Germany and help Germany in reaching your and their carbon neutrality. We are therefore very happy to continue the collaboration with Raisonné and look forward to follow up on these studies with market potential for a network in a coming market consultation. Thanks for listening, and now further to my good colleague and friend Hans Kønnen from Raisonné. Thank you.
Yeah, thank you, Torben. Can you hear me? Because I had some difficulties coming in, but seems to be resolved. Thanks, Torben. Yeah, and also a very warm welcome from the side of Gasunie. And we really appreciate your interest and participation in this webinar, where we, as Gasunie and Energinet, present our joint technical pre-feasibility study for a Danish-German hydrogen connection. And this is not an initiative which stands on its own. As Torben already elaborated, it is part of a larger context and vision on the energy transition. It's our firm belief that system integration is a crucial element in supporting the energy transition. We need the strengths of both the electricity and gas networks. Mix of renewable molecules and electrons will be needed to achieve our climate goals. We therefore see a key role for hydrogen in the future energy system. And Gasunie has the will, the ambition, and the knowledge to help shaping the sustainable hydrogen market. We do this by developing open access infrastructure in a timely and efficient manner. But companies cannot do this independently and on its own. Cooperation with partners along the value chain is key. By working together, we can and will develop this hydrogen market. With the initiative which we present here today, we build on a long tradition of collaboration between Denmark, Germany, and the Netherlands. In the past, we already successfully developed the gas connection between Germany and the Danish gas systems at the interconnection point of Hallund. And more recently, we have joined forces in the North Sea Wind Power Consortium. As part of the North Sea Wind Power Hub Consortium, Energinet, TenneT, and Gasunie want to unlock the offshore wind potential of the North Sea. The North Sea Wind Power Hub initiative is transnational, integrated, and a step change to a massive build-out of offshore wind in the North Sea. And this large-scale thinking is the only way to timely meet our decarbonization targets. The joint work on a hydrogen connection between Denmark and Germany, which we present today, is not an example of such a collaborative effort. Today we present how a large-scale hydrogen transport connection between Denmark and Germany could be developed. Connection from Denmark is an important contribution to the project Hyperlink, hydrogen backbone which Gasunie is developing in northern Germany. Our joint analysis indicates that 10 to 25% of the future German hydrogen demand can be imported via this envisaged network between Denmark and Germany. And by developing this connection, we can take a significant step forward in kickstarting the hydrogen value chain across national borders. This study and the webinar should be seen as a start. There are still many aspects that need further elaboration, and we look forward to further developing this concept in a dialogue with the market and stakeholders in a collaborative manner. I hope this webinar is a good start of that dialogue. I would like to thank you all for your attention, and I'm happily passing over the word to Louise, the moderator of this further session. Louise, the floor is yours.
Thank you very much to both of you for those welcoming remarks. I will just take back the screen so that you can again see my slides. So just if you slowly coming up, I think. All right, so we have now come to the first part of the session where we go through the findings from the study that we conducted between Gasunie and Energinet. And the first session is about the hydrogen supply potential in Denmark. And I will say a little bit about that. When you talk about renewable hydrogen production, it's very linked to the offshore wind energy generation, and that's often what you hear also when you talk about this potential of Denmark becoming a key supplier of hydrogen in Europe. And of course, this is not without reason, because we have quite ambitious goals for offshore wind development. And latest, the government announced a climate strategy for additional 6 gigawatt of offshore wind by 2030. And a large share of that wind is actually to be built on energy islands. One being an artificial energy island in the North Sea, and the other one being developed around the physical island of Bornholm. And until 2030, the goal or the target for now is to build around 3 gigawatt in the North Sea, but building the island so that it's scalable to 10 gigawatt for later possible investments. So there's a story around the offshore wind development, and which is closely linked to renewable hydrogen production. But not to forget the vast potential of solar power, PV, that is developing in Denmark, and it's developing without government subsidies. And in fact, we have seen signals of up to 16 gigawatt already by 2025. So those two developments together really puts a strong, makes it very attractive to produce hydrogen, renewable hydrogen in Denmark. When you're talking about sort of where is it attractive to produce hydrogen, it's of course both related to where is the source of production, but also other aspects such as access to district heating network, whereby you can monetize the excess heat from the electrolyzer units. Where are carbon sources for production of carbon-based PTX? Where do you have access to potential long-term storage of hydrogen, and so on? And that sort of serves the basis for why we have looked at Esbjerg and Holstebro as potential starting points for a hydrogen infrastructure network. Holstebro is unique and attractive in the sense that it's located close to potential long-term storage, geological storage north of Viborg, as you can see here and illustrated on the slide. Esbjerg, of course, district heating, but also the fact that Esbjerg has developed into this offshore wind hub in Denmark. And then, of course, also that there is a connection, or there could be a connection to a German market, which is rather adjacent. And then that if we are to repurpose existing natural gas pipelines, there is actually a double line system on that stretch from Egtved down to Elund, this one here. I don't know if you can see my pointer. No. So the renewable hydrogen potential very much linked to the development of wind and solar in Denmark. So moving on to the next slide here. So with this graph, what we're trying to show is the correlation between the wind generation and the classical demand. And as you can see here, there is the hour where you could say the production surpasses demand is almost close to zero when you look at this production profile, which is, by the way, aggregated and sorted. So it's not one wind production profile. It's seen as an aggregated. But the thing is, as we are moving towards more renewable energy generation, we will have more times, you could say, where there is an excess supply. In other words, there will be much more hours where production surpasses the classical consumption. And since in these hours it is often the prices of electricity is often so low that it is not economical to produce, this could be curtailed. But in order to utilize this excess production of wind, we need flexible consumption. This could be power to X conversion into hydrogen, or it could be other flexible consumption products. But the key point to make here is that as we move into the future, we will have even more renewable energy capacity. And the more we get, the larger this area becomes, where we are not able to harvest the renewable electricity unless we have flexible consumption such as power to X or hydrogen. So this is really part of why we are talking about producing competitive hydrogen in Denmark. The extent to which you can utilize this area, the more cost effective is it. And it's also what we call system integration, which we find crucial for the development of hydrogen in Denmark. Yes, and going back to the study, you could say, in the sense that we did try to project the export potential of Denmark, and the way we did it in the study was we looked at the Danish Energy Agency's 20-year projections that are looking at the electric consumption for power to X. And then we looked at and in the projection, it should be mentioned, it is assumed for national consumption. So we considered assuming that we have additional renewable energy capacity. This excess capacity could be used for export of hydrogen. And of course, this is generating a rather large bandwidth or range for export, both in 2030, 2035, and also in 2040. So important to mention, of course, is this is subject to quite a bit of uncertainty. I think in the light of the development that we are seeing with signals from the market, it's quite interesting to mention that already by 2030, if these plans that we see currently and that has been announced are being realized, we could actually already have 3 gigawatt of hydrogen by 2030. Yeah, and then since these projection doesn't reach beyond 2040, we have considered the 2050 scenario under the assumption that Denmark reaches carbon neutrality, and that in that scenario we could reach 70 terawatt-hour of hydrogen. So the potential is quite large, but it's also subject to a lot of uncertainty, which of course depends on market prices and also demand when it comes to import. And that leads me to the next part of this presentation today, which will be covered by my good colleague Malte, who will talk about the import potential of hydrogen in Germany. Malte, the floor is yours.
Thank you, Louisa. And before I forget anything, I would like to thank you and your colleagues at Energinet for the very good cooperation, for the great cooperation on this issue. Hydrogen demand and of Germany. Here, the word potential is very important, as Louisa said already, because we have a high bandwidth of hydrogen that can be used in the German market, and therefore there is no clear answer what will be used, but of course the potential is the right word. We can directly move to the first slide, maybe. If this works. We had agreed that Louise should share further on these slides, and I hope she will do that.
Yes, at the moment I don't see any slides being shared. Perhaps you could share the slides, Louise.
I can turn on. I can.
A few seconds and somehow I missed the presentation.
It's back now, I see.
Does
Yeah,
it
that's exactly the first slide I would like to start with, because when we talk about hydrogen demand in Germany, we talk about hydrogen demand for green or at least carbon neutral hydrogen demand. Therefore, the demand is linked to the climate targets we have or we will reach in Germany. Following a Supreme Court, if this is called Supreme Court in Germany, but a German Supreme Court decision months ago, the climate targets have been raised last week to 65% in 2030 and a full decarbonization in 2045. Therefore, that's very ambitious targets, and they are not in balance with the plans. We do not have, let's say, a master plan behind this energy. How should the energy system look like in 2050, which is somehow missing for us as infrastructure companies. We would look like we want to have something like that in the background, but we at least we have two clear decisions, cornerstones of the energy system. And these cornerstones for the energy systems are the conclusions that we need to have renewable gases in the system to fulfill the decarbonization. And the main driver is that Germany will not be energy independent in the future. It cannot be energy independent. We do not have the resources to create enough energy from renewables to be energy independent. And the other main argument, of course, is what Torben already said. There are sectors which cannot really be electrified. The concretization of the idea of having CO2 neutral gases in the system is the National Hydrogen Strategy that was launched in the last year. And the main direction of the hydrogen strategy is to have that making hydrogen a competitive option for decarbonization of the market. And the hydrogen strategy is based on 38 measures. And they are working on the three fields. They want to increase the production, they want to increase the demand of hydrogen, and of course, they want to build the link in between, which is the infrastructure for hydrogen. In this strategy, we have money. There are 7 billion euro for the market growth and production growth, and there are 2 billion euro for the development of international projects. In Germany, we have a lot of hydrogen projects, and reaching from hydrogen used in fleets of buses to multi-gigawatt electrolyzer ideas in the North Sea. Therefore, we have a lot of projects, and we are running actually in the IPCEI project round in Germany, which is now in the matchmaking phase. And somehow we are hoping that that the IPCEI will help as a kickstart for the overall development, since we are somehow lacking the next step. We have to come to a level when infrastructure is really relevant, and when projects are reaching, let's say, a magnitude that hydrogen has to be transported over the gas infrastructure. As I said, Germany will need to import energy, and of course, this energy import will be handled in the form of molecules and mainly not electricity. For the purpose of this study, we have selected basically 3 studies, which one study has 2 scenarios, and most of the scenarios are actually electricity-driven scenarios, like the Agora study and the Fraunhofer study and the electrification scenario from DENA. And only the DENA technology mix scenario is one which is relying on, let's say, a mix of technology and using more of molecules in the planning. The interesting aspect I want to would focus on is the role of hydrogen as being imported. DENA is somehow 3 years old now, and they have not taken into account the option to import hydrogen since there was no plan of building a hydrogen infrastructure. This changes with the new studies from Agora and Fraunhofer. We should move to the next slides. And this is the demand bandwidth of hydrogen in the different studies is reaching from, let's say, if you stick to 2050, from above something like 150 terawatt hours to more than or almost 400 terawatt hours. We could have selected different scenarios with much different figures for hydrogen, but the main purpose is to give you a bit of the ideas what is behind the demand in the different sectors. There is not one hydrogen demand, and the demand of hydrogen is basically new demand. Most of the sectors which we are talking to is not currently using hydrogen, except for chemistry, and therefore it's really the change from one energy carrier to hydrogen. And this development is, of course, strongest, let's say, if there's a real argument in the background why hydrogen should be used. And somehow with less and less argumentation behind it, the relevant sectors are steel, because in steel you need to have you have to do a reduction, a chemical process from the iron ore to get iron, and this can be done only with molecules like hydrogen. You have the chemistry industry, where hydrogen is relevant for the feedstock use. Hydrogen is already as a in-between project very, very relevant in chemistry. Here the question mark is where the carbon in the chemical components will come from, because that's another part which has to be put into the feedstock use. Refineries are currently using a lot of hydrogen, but of course there is no clear picture of refineries in the future unless you are talking about a lot of power-to-X development. Transport sector has very good arguments for hydrogen. Hydrogen has a high energy density. You have very fast refueling processes, but this is not currently so strong in the focus of the political development in Germany. And the last sector, which is under discussion, at least for the heating sector, is will hydrogen be used for heating, household heating, or will households be electrified? And linked to this issue is the question how much backup capacity will be handled by hydrogen or maybe methane in the role. That's what I wanted to say about the different sectors in the German market, or in all the markets. In the next slide, I would touch some aspect which we did not touch in the study, which is the northern area of Schleswig-Holstein and Hamburg. And this picture came from a study of the Schleswig-Holstein government, and they show the market and the production potential of this northern region. And why I did put this onto the slides is the statements, and even so, of course, in Germany, we are thinking about a wide-reaching hydrogen infrastructure, a wide-reaching grid of hydrogen connecting Netherlands to Germany to Denmark. There are potentials in a smaller view. Let's say if you look on Denmark in combination with the northern region of Germany, this could be something that is realizable in maybe in a faster track than something else. On the last slide, I tried to give you a bit about what happens on the network development plan in Germany. Problem in Germany is still that we have not the real path which leads to a hydrogen infrastructure, but we did, as TSOs, we did our homework in terms of planning, and one thing is that we developed a vision of a hydrogen grid. This is a green grid you see there in the background, which is very prominent. It went as parts into the European hydrogen backbone, but this is not based on a total planning assumption. There are good ideas in it, but it's not a planning to the last kilowatt hours. And in the Netzentwicklungsplan, in the National Development Plan 2020, we did a grid planning for hydrogen and the remaining methane grid based on a market survey. And based on this market survey, we developed the blue grid, which showing on this map is a map for 2030. And there is a plan for 2050 as well. And already in 2050, we had a connection between Bremen and Hamburg and the very northern market area, which is relevant, of course, to being connected to Denmark. Right now, we are in the process of doing our next national development plan. We have collected a market survey again, and we got the answers already, and we got answers on a different magnitude. We had 30 answers, 30 projects in the last market survey, and now we have several hundreds. And we had 3 gigawatts of demand in last survey, and this time we reach a different magnitude, as speaking as a physicist. But these results will be published in June. Therefore, I cannot give the details right now, since we are working still on the details. But our hope is that we will be able to show the demand for a much larger grid in the next national development plan, and this grid might include already the area of Schleswig-Holstein, therefore bringing the connection to Denmark even closer. That's from my side for the German demand development and a bit to the background in the national development plan. And Tine will take up the next part of our presentation. Thank you.
Thank you, Malte. Yes, I will give a presentation of the technical work we have done together with Energinet and Gasunie. I will present the transport corridors, some of our key assumptions and scenario results, together with some learning points. I can say we are still learning on this hydrogen transport system. So going to the next slide. I'm also learning the presentation, how to run the presentation here. We looked at 2 alternative routes from Denmark to Germany, as Louise mentioned, one starting in Esbjerg and one starting in Holstebro. They both reach south of Hamburg in an area with a small location called Heidenau. A region where there's a potential demand for hydrogen and where it's possible also to connect to a future hydrogen grid system supplying additional demand centers in Germany. 2 starting points shall be taken as possible landing points for energy from the North Sea energy islands, and not as fixed location. The actual location, if we ever build this system, will be dependent on the market needs. The yellow line you see on the screen here is repurposed natural gas pipelines, and the dark blue lines are new build pipelines. For the new build pipelines, we have used a dimension of 36-inch. And for the existing pipelines, the diameter ranges from 24 inch to 36 inch. So it has been a puzzle to connect these systems together. For the 2 routes, we see a potential for repurposing about 60% of the pipeline for the shorter route from Esbjerg, and a little less than 50% for the longer route from Holstebro. The 2 scenarios we show here is the 2 fully developed scenarios with a theoretical capacity of transporting 8.6 gigawatt hour per hour. And when I say theoretical, it's because it's steady state calculations we have made here and not dynamic calculations. To reach that capacity, We need one compressor station on the shorter transport distance, and on the longer one from Holstebro, which is about 100 kilometers longer, we would need 2 compressor stations to reach the capacity, the same capacity. As Louise also mentioned, the route from Holstebro has the advantage of being in the vicinity of the Danish salt cavern storage in northern Jutland. We see it's vital for a potential future hydrogen system that has access to flexibility, for example, from a storage to balance the fluctuating hydrogen production from renewable energy with a need for a stable offtake at the demand side. So that takes me to next slide. Here I have presented some of our technical and cost assumptions, and I will not go through all of them, but I want to point out a few of the more critical ones. On the technical side, it's the conversion of methane gas pipeline is possible. That's the assumption we have made. And also that the converted pipelines can be operated at the same maximum allowable pressure as we can for natural gas pipelines. Both of those assumptions are critical for both the capacity of a transport system, but also for the cost of the transport system. Both assumptions, I would say, is today generally applied when we look at European studies, but there's very little experience to verify that it is actually possible. In Gazini, a few years ago, they converted a pipeline in Netherlands and gaining experience from that. And in Energinet, we this spring initiated a technical study to find out how and if and how pipeline from exit to the border can be converted and at what pressure it can be operated. We really look forward to obtain the result of this study. Cost-wise, there's actually also quite limited information. We based our cost estimate on the European Hydrogen Backbone study and on the cost figures in the German development plan. And I would say that we believe the cost estimate are a best estimate we can do with the current information, maybe a little to the conservative side. One thing I want to mention here is also that we have excluded from this study the cost of acquiring a natural gas pipeline. So that is for future studies to include. Now, looking at the results of the study, I show here on this figure the maximum theoretical capacity on the left y-axis, and on the two right y-axis, I have first the maximum power need for transporting that capacity, and the yellow line is the total investment cost. So the graph shows that a transport corridor from Esbjerg to Heidenau can be established for about 390 million euros, and from Holstebro to Heidenau about 610 million euros with a capacity of 2 to 2.5 gigawatt hour. That is without compressor stations. And if we then increase the capacity, we can add compressor stations on the way and reach a fully development system with indicative cost of 670 to 875 million euros. The operational costs are not shown here. We have some indication in the report, but they will depend on the capacity being transported in the pipeline system, and not the theoretical capacities. I would like to make 2 comments here because that's also some of the learnings we have done. If you look at scenario 2 and 3, it's the same route from Esbjerg to Heidenau. From Esbjerg to Heidenau. we have a different location of the compressor stations. You can see that the capacity in scenario 3 increased with about 1/3, but also the compressor cost, need for compression, increased with about 2/3. So it's very important how and where we locate the compressor stations and how we design them. The same applies for scenario 3 and 4, where we have 2 different routes, but with the same maximum capacity. And actually, you can see here that the longer pipeline from Holstebro actually have a little lower need for power than the shorter one from Esbjerg. So one of the learnings we take from this study is that we have really to carefully design and locate the compressor stations to reduce the overall cost of this transport system. Before I conclude on the technical part of the study, I would like to thank our colleagues in Gazini for a very fruitful cooperation. And I think I can also say, at least on my own behalf, but I think also on the team member, that it has been very interesting and instructive months we have spent doing this study. The key messages we would like to bring to the board, to the table today, is that the system can be built, it can be constructed. It of course depends on the market needs. We can do it. We see we can do it flexible. It can be done scalable and in steps, depending on the increase in demands, and it can be done efficiently by, for example, repurposing pipelines, but also carefully study compressor installations, locations, and how to optimize and reduce cost on those. What we need is clear market signals. Malte mentioned there's been a market survey in Germany. There was also one in Netherlands this winter. And I'm actually very pleased to announce that in the coming months, the Danish Energy Agency and Energinet expect to launch a market dialogue on the demand of hydrogen transport capacities. We see the market dialogue as a first step to gain feedback from the market with respect to the need for hydrogen pipeline infrastructure. And we invite projects of all levels of maturity to participate in the dialogue. The outcome will serve as input to the ongoing work with the Danish National Power-to-X strategy in the Danish Energy Agency. And it will also serve as input in future grid planning for both electricity and gas in Energinet. So yeah, we invite you to participate in this dialogue. And I think that's the end of our presentation, and we open for the Q&A session now.
That is right. Thank you, Tine, and also thank you, Malte, for your presentations. I can see in the chat there's been quite a few interesting questions, and that is good that we have some time to address them now. We have received questions related to market and also related to technical things. We will try to address, you could say, a broad spectrum of interest from the audience here. Let's start with the market. There's been some questions in relation to the market. One of the questions was, how will it be financed? And it's a good question. And in relation to that, it's important to mention that this is a pre-feasibility study. So we have not looked into aspects related to financing. Of course, in order to be able to answer that question, we need to go further and understand what is the actual needs from the markets, as Tine also mentioned. So we don't have an answer to that now. That will have to be looked into in future work. There was another question in relation to the market. regarding the integration of the Swedish market. And in relation to that, I think it's important to mention that we have also done some work under the European hydrogen backbone, and maybe some of you have seen that there are connections also to other countries, including Sweden. So yeah, in that respect, I would say there's both, of course, a potential for exporting hydrogen to Sweden, and we do see potential, especially in the northern part of Sweden, from industries using hydrogen. In relation to the German market, you could also see Denmark becoming a transit system from hydrogen produced in the North Sea, partly maybe coming from Norway. So Sweden is, of course, also an area that could be interesting to explore further. And this is an example of a cross-border connection where we see some potential, but of course, looking into other cross-border connections for export of hydrogen is also interesting and could be explored further. There's another question here related to the import, and I'd like to address this question to Malte. The question is, why is the potential import demand Power-to-X expectation strongly reduced in more recent studies, while in Germany, the decarbonization targets have increased first to 55% and now to 65% by 2030?
Yes, good question, but I think I was a bit too fast on this demand studies. Maybe we switch to the demand studies, because the statement is not that the demand is reduced to the targets, because all of the studies we show are 95% or 100% are therefore deep decarbonization scenarios. Therefore, it's not the demand of energy which is needed to be imported to Germany is not depending on the target, but it's depending on the overall assumption you have in the I think the first let's take this one, because this one is showing somehow the missing supply of, except for a bit of electricity that might be transported as well, but this is showing the import needs of Germany, and this depends on the strategy that is followed in the study. And if you have a high electrification study, therefore pushing electrification to the limit, you usually have a very energy efficient scenario, because you, for example, you do a very good isolation of buildings, and therefore you can use heat pumps and you have a very little demand of overall energy. And therefore the left and the two right ones are strong electrification studies, which are roughly the same level. And the middle one is something which is not pushing efficiency to the limit, and therefore there is a higher need of import some form of energy, and that's a signal. Therefore, it's not yet. We do not have yet a study which is taken into account fully the speed up of the decarbonization. One exception is maybe Agora. They have a fast track scenario in that study as well, but therefore this is something which is coming up in the next time.
Thanks, Malte. Another question which is more technically related. It goes like this: what technical work was done to support conversion is technically feasible, and what has to be done, for instance, safety measures to make this happen? Tine, perhaps you could answer that question.
Yeah, I can try to answer it. As I mentioned in my presentation, we have made the assumption that conversion repurposing is possible. And as Energinet has initiated a study, a consultant study this spring, to deep dive into the quality of the pipeline, the current pipeline, the welding methods, the coating, everything, to make a conclusion if the pipeline can be converted safely and at what operating pressure it can be operated with hydrogen. So we do not have a clear answer at the moment. We expect the pipelines can be converted, because we know what the steel quality, and that is generally accepted to be possible to repurpose. But the interesting question is, at what pressure can it be operated? If it's very low pressure, it might not be too interesting to repurpose it, but we are still waiting for those results. I don't know, maybe if you have some additional knowledge from Germany, Malte, on the technical feasibility of repurposing pipelines.
And not such much as knowledge, but we are describing a bit of the process. Yes, we are exactly on the same topic. We're checking what is possible and what is necessary to repurpose pipelines. And this is tackled on different levels. We have in Germany several TSOs. We have 16 in overall, and therefore few of them are taking up concrete studies to repurposing concrete pipelines to hydrogen. And at the same time, we are in the process of preparing the DVGW, das ist der Deutsche Verband Gas und Wasser, which is doing the technical settings, the technical limits, technical rule books for hydrogen transport. And this is now prepared to include necessary infrastructure for hydrogen pipelines, repurposing pipelines, what is necessary to repurpose them, and new build hydrogen systems, of course, and all the aspects that's connecting power to hydrogen units and so on, electrolyzers. Therefore, it is tackled on that level, and but right now we are seeing it as given that we will be able to repurpose pipelines, and most likely with a given with a maximum operational pressure, and that's the background why we chose this parameters in the study.
Thank you, Malte. And perhaps you can also answer the next question, which might have been mentioned throughout the presentation, but anyhow. The question goes, how and to what extent do you want to run gas and hydrogen in parallel?
Yeah, we are, our planning is based on keeping up a parallel system for methane and hydrogen. And the background is that we see a future in methane, especially we as Germans see with enviously your hydrogen methane production from biomethane plants, and therefore there might be import is needed as well for methane in the future for green methane. That's a long-term run, but currently we keep up the methane capacities in parallel, and that's independent. We do not prognose, or we take into account a decline of methane demand. That's we can keep up the demand, the current demand, even with the conversion of part of the infrastructure to hydrogen.
Thank you, Melle. Another question was also related to the current methane system. The question is, how will you integrate the new Baltic pipe? And I'll try to answer that question, and for the Danish colleagues, feel free to fill in if I'm missing anything. But for the envision pipeline that we are looking at here, we are not looking at aspects that are where the Baltic pipe from Norway is running. So currently there is a double line from Esbjerg to Egtved, and I almost want to show the system, but we are not considering repurposing of natural gas pipelines that are currently transporting Baltic pipe methane. But I don't know. Perhaps Torben, you would like to fill me in on that.
Sure.
We're trying to say a few words. Yeah.
Can you hear me?
Yeah. Yes.
I can try to, let's say, draw a few lines to the introduction. So many of the questions is, let's say, asking for, let's say, exact answers, or let's say, how is this going to be regulated in detail in Denmark? And we are not in that level. We are like any other member state. We have the luck that we have so much renewable energy that we are probably front runners in integrating renewable electricity and renewable gases in our system. So we are also part of this hen and egg problem. And this studies, let's say, for us, let's say, normal that we take the best information we have about our system and then give it to everyone in a transparent way, and then they can use it and come back. And I think the European Hydrogen Backbone is also let's say, taking some points there. We have for the last 6-7 years, as I mentioned, prepared system perspective plans for electricity, heat, power to X, natural gas and hydrogen, seeing the systems together. And I think we have a fairly good, let's say, overview, but to be honest, we don't really know what to do. And therefore we have several studies in the power side or in the gas side conducting this, but it's also up to, let's say, a political decision on what should then be, let's say, the proposed responsibility sharing between the players in the market. On Baltic Pipe, that project is, let's say, fully integrated in the existing system. So we are utilizing a lot of the existing infrastructure, which is not prepared for hydrogen because we put it in the ground 30 years ago. But we have tested that we could take 10, 15, or perhaps even more % hydrogen blended into that. But what we're looking at now, and also in particular in this study, is not, let's say, the blending scenarios. It's more the pure hydrogen infrastructure components. And this is where we then test the German Danish connection. And if you look at the hydrogen backbone study, you can see that even Sweden, there might be 1 or 2 connection opportunities that we will assess. For the Baltic Pipe, we are even considering in the longer term, how can we use Baltic Pipe for green gases? Because for sure, Baltic Pipe will include only green gases by 2050 as part of the European commitment towards the Paris Agreement. And also what we have seen in the last years with the Polish, let's say, push for green gases, biomethane and hydrogen. I think that they are, let's say, increasing more and more, let's say, a focus on green gases. One final topic, if you allow me, that is on storages, which also is mentioned here. And for sure that the Energinet storages in Gas Storage Denmark, they are included. So we are having the Green Hydrogen Hub project Denmark, where we are assessing how to take, let's say, first a smaller cavern, but are willing to consider how we will take 1 or 2 or even more caverns out and convert them into hydrogen, because we see that what is needed in the future energy system is need for flexibility, balancing, longer-term storage, etc. And for sure, the existing competences as infrastructure components could play crucial roles there. Thank you.
Thank you, Tom. Yeah, let's see. There are more questions coming in here. One of them, one of the more specific question again is also related to the financing. It goes, do you envision long-term offtake contracts for hydrogen and guaranteed prices? That's again a question that we're not able to answer at this point in time, but if it's of course a remaining and recurring question and discussion also at the European level. How do we finance these infrastructure projects, particularly since we don't have a customer base at the current stage? So it's of course very different than what we are used to, and also what we were used to, or you could say when you started regulating the natural gas system. With hydrogen, we need to start both with supply and with the demand, and also with the infrastructure. So finding good ways and models to get the market off the ground is really crucial. We don't have the answer, but that's of course part of what needs to be looked into further if infrastructure projects in general are to be moved forward. But of course, important to realize that the EU has actually put aside quite some, as also Torben was mentioning in his welcoming remarks, has really bet on hydrogen big time, and is also, of course, opening up for different ways to apply for funding. I know especially the Germans have applied immensely into the IPCEI, and Malte was also mentioning that Gasunie is involved in a number of projects. Danish companies have also participated on the Danish side in IPCEI, and now we are going to see this EU matchmaking process, and hopefully that can also lead to you could say this market developing faster or in due time with respect to the targets that's been set out by the EU. And of course, national as well schemes looking to support this development. But yeah, that was a long answer, but that's a good question. It should probably be looked into further.
Louisa, can I add on?
Yes.
So I think it's fair to say that in Denmark we will have clear roles and responsibilities. So production and consumption will be, let's say, commercial, private entities taking that role, and the infrastructure, let's say, could be, let's say, shared on different parties. We have a strong, let's say, a tradition that, let's say, company like Energinet, we own the overall highway or transmission components, but there's also, let's say, distribution and even, let's say, the possibility for private, let's say, entities owning the infrastructure. So I think what we're seeing right now is that no one can take an FID because we don't have an overview on the exact value chain. We are preparing study better and better cost estimates. They go into the, let's say, the political discussions, and then the parliament will hopefully later this year prepare a power to X strategy where there will also come guidance in, let's say, the role for Energinet. Should there be regulated transparent tariffs for some, let's say, routes, and then other places you might have, let's say, negotiated access in a more, let's say, industrial environment, at least for some years in a transition phase. So I think the discussion in Denmark is parallel to what it is in other countries, but we are not, let's say, the average country. We are, as I said, really front runner. So I think also that the decisions we will prepare here in Denmark is what is, let's say, fitting our starting point the best. Thank you.
Thank you. And Tina, I think you have something to add.
No, it's more another question on storage. Question, are there in the study access to more than one storage facility to secure competition on flexibility? And I just want to address it because this study is made by 2 gas TSOs. So we have not actually involved the storage companies in this study. We have both in Denmark and also in Germany good facilities for hydrogen storage in the future. So it's not up to us as transport operators to pick a storage. We just show a possibility that storage might have a value on the system analysis and optimization of a transport system.
Super. There is another question here, moving away from storage for a bit. And this is, the question goes, what's the expected lifespan of this pipeline made with a combination of a new build H2 pipeline and compression and an older gas pipeline? The gas pipeline seems to be a bottleneck. And I don't know if we can answer the exact question, but I don't know, Malte, if you can share some thoughts on this question, on the lifespan of the pipeline.
For all practical purposes, I would say forever, basically, because let's say if we take a security of pipelines and we plan them, we are planning them that they can last basically forever. Of course, we have rechecking measures and everything like that. And in the if this question was intended to be a technical question, therefore we have a long lifetime, of course, which we take into account even for repurposed pipelines. And the other aspect is we are entering a sustainable world. Therefore, I think that's hopefully some world which can run like this for a very long time, and therefore this should be a concept and which is used for some unlimited time. That's for the answer from the scenario world, I would say.
Yeah, I agree with you, Malte. Of course, there's a high maintenance level and integrity of the pipeline system, and we will in no way jeopardize the safety of the pipeline system we have in Europe today. So very important to make sure we have the high integrity.
Great. And more questions are popping up here. One is, will Energinet run hydrogen distribution grids in 2050? That's a good question. We don't know who will be owning and operating hydrogen pipelines in Denmark. According to the current regulation, Energinet has a mandate to run and operate natural gas pipeline and electricity pipelines. This question will be difficult to answer at this stage. And of course, also maybe to just clarify also, we are currently only, as Torben was mentioning, operating the highways, so to say, the transmission lines of electricity and gas in Denmark. There is a question on the cost. What is your assumption of transport cost per megawatt per kilometer of H2, also compared to natural gas? I'm going to pose this question to you, Tine, but I'm also going to say that this is something that we looked into and did not include in this study. So I'll have to say that maybe we will owe you an answer on this one, but I'll give you the opportunity to try.
Thank you, Louise. Yeah, I think we will have to come back to you on that one. We have done some preliminary analysis, and I think we shows that they are in the same range as the transportation cost in the European Hydrogen Backbone Study. And I think it's around, no, I don't dare to say the number, sorry, but it's the same range as you can find in the European Hydrogen Backbone Study.
Thank you. All right, what else do we have? We have 5 minutes left. So I think since we only have 5 minutes left, it's maybe a good idea to address the question, what is the way forward? And the next question, is there going to be a feasibility study? So maybe just I would like to restate Tine's words from her presentation. We are going to initiate a market dialogue in collaboration with the Danish Energy Agency on the Danish side to understand the needs for hydrogen transport capacity in Denmark. Depending on the outcome of that study, we will know whether a step forward could be a feasibility or other initiatives for the specific study. But this we are doing with the Danish Energy is an attempt to try to move forward with these inquiries that we get on hydrogen infrastructure development. I don't know, Malte, if you would like to, or if you would like to add a bit, Tine?
I think it's fine with you.
Okay, and then I think Malte, maybe perhaps you would, or I could maybe say that of course we will continue the collaboration with Gasuni, and of course we will also follow up with you in the market. We would also encourage you to get back to us afterwards if you'd like to discuss a little bit more the potential and the prospects from your perspective for this infrastructure that we have been looking at in the study. I think the short answer is that we will look into how we can, you could say, move this forward. But of course, this will depend on the interest of the market, and that's why we will initiate a dialogue in relation or in collaboration with the Energy Agency. And Malte, I don't know if you would like to add a few words on your planning, perhaps.
Because I totally agree. I think the interesting part is the market interest, and that we need to have customers which are really able to use hydrogen and produce hydrogen and see a good enough situation from cost situation, from legal situation and everything, that they are daring to decide on building the very expensive generation of hydrogen and switch their steel plants or whatever to hydrogen. That's something which is the next step. And the technical aspect we have brought to a very good level in the way that we can provide an infrastructure with a very relevant capacity for feeding hydrogen to Germany. And that's, I think, the main signal. Therefore, I do totally agree. Market is a relevant thing, and I'm very happy that you have announced today these plans of Energinet. That's very great.
Excellent. I think we still have time for one question. There's one on, is there a platform to discuss with Danish and German governance, transport sector, industry, chemistry on opposite costs to reach emission reduction and CO2 targets, costs that both countries, industry, transport sector and others have to take if they not use hydrogen, but still have to deliver their emission targets? The person that raised that question, could you maybe turn on your mic and just perhaps elaborate on your question?
Yeah, this question I raised was more than the focus on if we have also somehow a communication platform with all these participants on their costs that they have to bear if they not use the hydrogen via the pipeline route coming from Denmark into Germany. But on the other hand, they have to take measures on their emission reduction, especially to the new emission plan in the EU. So that because you talked about the prices,
Right.
which can be possible on transporting hydrogen and produce hydrogen, but it's also interesting to know about the opposite cost that they have to be anywhere.
Definitely, and it's a good question. I would maybe mention again, or I think it may have been mentioned by Torben, the launch of the Clean Hydrogen Alliance under the European Commission, which has set up 6 roundtables that kind of covers the entire value chain of hydrogen, both from production and also the consuming end of the value chain. I think that's a unique platform, and I think that's a good place to take those discussions about pricing and market, and what are some of the bottlenecks in order to get the market accelerating. So that would be my immediate suggestion. All right, I think we're running out of time. Actually, we have spent a bit more than what we promised, but that's also because there were so many good and interesting questions. So I think we should round up the session here today. So lastly, thank you everyone for joining the webinar. It was very, very interesting and very happy to have a dialogue and get so many comments and also questions on the study. So with those words, let's stay in touch and hope to see you again at another hydrogen related event. Yeah, thanks again and have a good day.